Okay, this is going to be a fast video of a Mann-Cova, right? It's a multiple analysis of a covariance. So, the C stands for covariate or covariance. We're going to run this through SPSS. I'm going to try to make it a short video. Sometimes it's kind of hard. But we're going to use the data from the rat study, which we also did the two-way ANOVA. I believe there's a three-way ANOVA. Same basic material, same data. We just add a couple of columns, new variables as we go. But in this Mann-Cova, DV1 is the number of sit-ups. DV2 is the number of push-ups. IV1 is the drug dose. IV2 is the smoothie size. And again, this is the same data that we ran in the MANOVA and I believe the ANCOVA. But there's our two IVs and our two DVs. So with the covariance, we're looking for covariates, okay? There could be more than one. But let's start with the assumptions. Assumption number one, sample size. Real quick, let's look at all the assumptions. So the assumptions of a Mann-Cova are simply all of the assumptions from the MANOVA and all the assumptions about the ANCOVA. The ANCOVA, you'll notice that it's all about the covariates, okay? The assumptions of the covariates plus the assumptions of having more than one DV from your MANOVA. Okay, so let's get back to our sample size. Sample size. So we got two IVs, two DVs. You got to look at this like a cell structure. So here's IV1, okay? It's the three different levels of the drug. We got two different IVs. So if you look at it this way, we got 6 cells. There's got to be a minimum of the same amount of DVs in each cell. So we have 2 DVs. The minimum number in each cell would have to be 2, 2, 2, 2, 2. You add those all up, you get 12. But we have a lot more than that. Right? We have 6 per. So that's 36. We have a total of 36 rats in this study. So sample size is not going to be a problem. And here's IV2, same thing. Right? There's only 2 levels of IV2, and we got 9 in each. So we did not violate the assumption of sample size. So back to SPSS. Second thing we're going to do is check the normality. So when I say normality, it's just the normality of the DVs. So give me a second while I pull up SPSS. Multivariate normality. There's more than one way to do this, but I always do it the same way. I simply go to Analyze, Descriptive Statistics, Explore, kick in my DVs, which are push-ups and sit-ups. Look for the statistics. Now we're going to do outliers with the Mahalanobis for this, because as we already know, a MANOVA or a Mann-Cova is very, very sensitive to outliers, okay? But let me see what we got here. Plots, nope, not that one. Plots. There you are. Histogram, that'll tell me if it's normal. Along with the normality plots. Continue. So SPSS, there's 36 in the push-ups and the sit-ups, nobody missing. And there's the means of the push-ups, means of the sit-ups. Here's our normality test, the Kolmogorov-Smirnov test. So the push-ups or the sit-ups was not violated the assumption of normality. So we're good to go. That kind of looks pretty normal. Not perfect, but not normal. This is pretty good. Don't look at that. So the push-ups, no outliers. Here's sit-ups, kind of kurtotic. And here's sit-ups, no outliers. But again, we're going to look at the outliers next. So we have not violated normality in the DVs. So next assumption is outliers. So that's when we're going to use the Mahalanobis test. In order to run a Mahalanobis test in SPSS, we have to make a fake IV, and that's the one we just call ID, and we just number it 1, 2, 3, 4, 5, 6, all the way down to 36. Just to trick SPSS. So to use the Mahalanobis test, you got to go to Analyze. It's in regression, but remember, this is not a regression. We're just using the Mahalanobis test. So our DV is our made-up IV. Okay. And our independent is the sit-ups and the push-ups. And we're just looking at the Mahalanobis. We could also use the Cooks, but again, I'm more of a Mahalanobis kind of guy. Go down to the bottom of the screen, click Continue, click OK. Don't look at anything in the regression except for the residual statistics box where it says Mahalanobis. Okay. And again, it's the same thing that we got from our MANOVA, but remember, this is a MANCOVA. So we got 4.9. That was our maximum. I'm going to show you something different using a spreadsheet calculator. So hold on. And it's right here on our web page. Go ahead and open it up. Okay, open up your spreadsheet. So alpha is 0.05. That's the cutoff. So N is the number in our subject. So we got 36. K is the number of IVs. We have 2. You hit enter. Bam. So our biggest Mahalanobis distance number is 13 point blah, blah, blah. So we got to go back to our list and check to see if our maximum Mahalanobis distance was greater than 13, and it was not. So there are no significant outliers affecting either one of our DVs. So that's it for outliers. So assumption number 3 has not been violated, no outliers. Thank you, Mr. Mahalanobis. All right, linearity, here we go. So linearity, as you recall, we're going to look at the matrix scatter plots. So let's go back to SPSS. Going to go to graphs, legacy, scatter, matrix. We need to define them. So the matrix variables are going to be the DVs. So that's push-ups and sit-ups. Our set markers by is going to be the IV. And we can only do them one at a time, I'm afraid. And then we're going to click OK. And so for the strength serum drug, you can tell right off the bat that for the push-ups and the sit-ups, they do form a pretty close to a straight line in there. We're going to repeat it with our smoothie size, graphs, legacy, scatter dot, matrix, define. So we're going to kick out the first IV, and we're going to kick in the second IV. And we're going to hit OK. And again, the linearity is pretty obvious here. Okay, so it looks like we did not violate the assumption of linearity. Assumption number 5, homogeneity of regressions. That has to deal with the DVs if you're putting them in some kind of order of importance. And we're not going to do that, okay? Again, if you are putting your DVs in some kind of order, you need to go online. There's a lot of different web pages that will explain how to do this, but we're going to skip it for ours. Moving on. Multicollinearity and singularity. Okay, let's start with singularity. That's if you take 2 DVs and you sum them and turn them into one big new DV. Okay, that would actually turn your MANCOVA into an ANCOVA because you only got 1 DV. So we're not doing that. So we did not violate singularity. Multicollinearity has to do with the correlation between the DVs. So let's take a look at that. So we're going to go to Analyze, Correlate, Bivariate. Our DVs are the push-ups and the sit-ups. So remember, we need a correlation somewhere between 0.3 and 0.8. Anything over 0.8 is bad, okay? Correlations, sweeping the nation. Okay, perfect. So between push-ups and sit-ups is 0.745. So it is significantly correlated, but it's not too strongly correlated. So we did not violate that assumption either. Moving on. Last assumption from the MANOVAs. Homogeneity of the variance-covariance matrix. We have to run the ANOVA for that. That's the one where the box M test will tell us. Remember, and that's not violated unless that p-value, that significance value, is less than 0.001. Let's go ahead and run our MANCOVA. But before we do that, we need to check the assumptions of the covariates. I apologize, I almost forgot. So in our study, we only have one covariate, it's age. So what are the assumptions about age? First of all, assumption one is, was it measured before any of the tests was run? Yes, it's on our data sheet, and we didn't use it in any of the analyses. So it was pre-existing collected data. Okay, it was recorded beforehand. Assumption two, we're assuming that they recorded the data correctly, reliably, and this is the age of the rats in weeks. So again, we're assuming that. Number three, the correlation between the covariates. We get to skip that because there's only one covariate. Okay. But in a different study, if you had more than one covariate, you have to check them first. Okay, whatever, if you think age or social economic status or some kind of pre-test value score could be affecting the DV, you need to run them first to make sure they're not overly correlated, too strongly correlated. But we're okay on number three. So linearity between the covariate and the DV. So let's go do that. With this assumption, we need to check to make sure that there's a linear relationship between the covariate and the DVs at each level of the IVs. So let's go ahead and do that. Okay, to check that linearity of the DVs, we're going to go to Graphs, Legacy, Scatter Dot, and we're just going to pick the single one this time. Define. SPSS can only do one DV at a time, so let's pick the first one as push-ups. Very important, the x-axis is your covariate on this, so let's plug the age in for covariate. And then the set markers is the IV, so let's kick in the strength drug serum. You're going to click OK. And we're going to get a scatter plot eventually. Ta-da! So remember, we're looking for linearity here, so let me fit this in the screen a little bit for you guys. Okay, it's kind of obvious. You can kind of see the straight line in there, but let's get an R, a correlation score. You're gonna double click on this. It pulls up this. We're gonna add a trend line. So the trend line that gives us an R squared of 0.769. So if you took the square root of that, that would give you a pretty strong linear equation. It'd be around about 0.85 for R. So that's good, right? That means that the DV and the covariate is strongly correlated at each different level of the strength drug. Okay, so now let's repeat it, substituting the strength for the smoothie size. So please hold. We're going to go back up to Graph, Legacy, Scatter, Simple, Define. Okay, out with the strength, in with the smoothie size, click OK. Okay, so here's our smoothie size. Same thing. You can tell right off the bat that it's got a good fit line. It should be pretty much the same thing as the other one. Okay, so hopefully they'll be almost equal. So let's double check. And let's add our trend line. And it's exactly the same thing. So our linearity of the DVs with the covariate assumption has not been violated. So the linearity is okay. Bam. So this assumption talks about the relationship between the DVs and the covariate at each level of the IVs. And the important thing is we do not want interactions. Okay, so we're going to graph these, and if they cross, just like always, that means an interaction somewhere. So that's what we're checking. We do not want the interaction between the covariate and the DVs at the different levels of the IV. Okay, to figure this out, it's almost just like the last one, the last assumption we did. We're going to figure it out with a scatter plot. We're going to go to Graphs, Legacy, Scatter Dot. We're going to pick the Simple again, click Define. Right? Hopefully everything should be in there from the last one. Okay, I'm going to switch the DVs, taking out the push-ups, putting in the sit-ups. Everything else should be okay. There's going to be a different button to click here. But okay, click OK. Get the graph. You're going to double click on this graph, and then you're going to click a different line up here. You're going to hit the one with set. So here's a single line. Subgroups, that's us. Boom. So it's going to do every level. Uh-oh, we got a problem. Okay. So for your smoothie size, we have an interaction. So we have an interaction between the regression slopes, between the covariate and the DVs with the smoothie size. So let's check the other ones real quick. Click out of this. We're going to go back to graphs, legacy, scatter, same. So let's kick out the sit-ups. Now let's leave the sit-ups in, but let's change the smoothie size to strength and serum. You have to do this for each and every one, so I'm just going to do them as fast as humanly possible. Okay. There's our graph. Double click. Double click again. Right? Bit line by subgroups. Close this silly thing. And again, it looks like two of the levels are okay. They're not interacting for the drug group, but one is. So it looks like you have one interaction just between one level of the IV. Okay. We'll do it one more time real quick. This time I will switch the DVs. We'll do strength drug first. Click OK. Double click. Add subgroups. Close silly box. These aren't bad. There is a minor interaction somewhere between the strength, right, the 0, 10, 20 milligram groups and the DVs, but it's kind of minor. And then the last one would be graphs, legacy, scatter. Simple. And I'm taking out the strength and putting in the smoothie. Click OK. Double click. Add subgroup lines, close silly box. And again, you do have some minor interaction there. So it looks like we did violate the assumption of homogeneity of regression of slopes. Since all of our covariates were not interacting with each other, I'm going to invoke the robustness of all ANOVA tests. That's a MANOVA, ANCOVA, anything with that in it. And say we're going to go ahead and continue because we didn't totally violate that assumption of the homogeneity of the regression slopes. So let's go ahead and do our MANCOVA. So to do a MANCOVA, you could do it from the output sheet. I didn't know if you knew that or not, but you can go to Analyze, General Linear Model, Multivariate. DVs are your push-ups, your sit-ups. Fixed factors are your grouping IVs, strength drug, smoothie size. Covariate is age. Okay, the model's preset. We're not doing any contrast, but we should look at the marginal means. Let's do them both ways. We'll do drug as the horizontal, smoothie as the separate, add, and let's do it vice versa. Drug as the separate and smoothie as the horizontal, add, continue. And then for options, it's always the regular thing. Overall, we always want the descriptives, effect size, power, homogeneity variance. I should click that. Click OK. And we finally get the results of our MANCOVA. So let's take a look at it. All right, general linear model. There's how many people were in, how many of the rats were in the levels of the strength drug, smoothie size. Here's your overall statistics. There's your push-ups with your 3 different levels of your first IV, 2 different levels of the second IV. Here's all the means and the standard deviations. Okay, so remember, it's looking for a significant difference between the groups and to see if a covariate is affecting the DV. So here's your box M test. This tells us way back with the MANOVA assumptions about the homogeneity of the variance-covariance matrix. If this significance number was less than 0.001, then you would have violated it. So we did not violate it. That's good news. Okay, next important box is the multivariate test box. So what this does is it looks at the different IV levels at all of the DVs combined overall. Okay, it's not the true F, but it will tell you if there was a significant difference between your drug doses, your smoothie size, interaction, and if age was in fact a covariate. Okay, so like always, the first thing you're going to look at is interaction, because remember, if you got interaction, you really wouldn't look at the main effects of your IVs. So our drug dose and smoothie size interaction, there's our significance. Yeah, so we got a significant interaction there. So we would not look at the main effects of the IVs, even though the drug dose, okay, there's a significant difference between the level of the drug doses, but it must be working together with one of the smoothie sizes. So that's what's going on. And you could look at age as a covariate, and we look at the significant value, and it's less than 0.05. So in other words, age was in fact affecting the DVs. Okay, so that was a good call. Now, which one of these statistic measurements we use here is we always look at the Wilks lambda. Okay, depending on your teacher or the book, a lot of times they can use the Palais trace, but it has been my experience that most of these numbers are relatively the same anyway. But we look at the Wilks lambda. So the Wilks lambda is what tells us if there's a significant difference overall concerning the DVs. Okay, so next box. There's your Levine's test. Okay, so we did not violate the assumption of homogeneity of variance. So far, so good. And then here's your money box, right? Test of between subjects effects. Okay, from the corrected model, there's an overall F, but we got to be careful here. That really doesn't mean what we think it means. So we don't look at the corrected model row or the intercept row, but let's look at age. So age on push-ups, that's the first DV. There was a significant interaction. There's a significance there. So in other words, age is a covariate only on the push-ups, not on the sit-ups, right? Because the push-ups is less than 0.05. So age is affecting the number of push-ups they do, but not the number of sit-ups, okay? And since we have interaction, which we knew that from the multivariate box, we're not going to look at the main effects of the drug dose or the smoothie size, but look at this interaction for push-ups. Very, very significant. So something about the different drug level and the different smoothie size is affecting the number of push-ups these guys do and the number of sit-ups. Not as significant, but it is still under 0.05, so therefore it is significant. So the interaction between one of the drug doses and one of the smoothie sizes is affecting the DV. Plus age is affecting the push-ups. So that's it for now. I sure hope this helps. I'm going to go down and look at the graphs real quick, but we already know that there's interaction, okay? So we really don't need these to interpret what we just figured out from this box. So that's it. I knew it was kind of long, kind of hard. But MGZ, out.